Let's do some practice with carbon dioxide emissions. Number 1. Your friend uses 25 gallons of gas using his speedboat over the weekend. Approximately how much CO2 pollution does this cause? Okay, we're using gasoline and CO2. So that should trigger the 19.8 pounds per 1 gallon of gas identity ratio. And if you want to know CO2, you want your final answer to be in terms of pounds, which means we need to get rid of this gallon. Well, it works out nicely for this one because your friend used 25 gallons. So that means the gallons cancels out with gallons and I'm left with just pounds. I multiply in the numerator and I'm left with 495 pounds of CO2. Number 2. How much CO2 is produced by driving 600 miles in an SUV that gets 38 miles per gallon? Well, again, CO2, we're talking about cars and gas, so that triggers 19.8 pounds per 1 gallon of gas. And again, the question is just how much CO2, so we want our final answer in pounds, meaning get rid of gallons. So gallons is going to go on the top. I have 600 miles here, 38 miles per gallon. Remember, per is that division sign. So 38 miles per 1 gallon. That right there makes my gallons go away, but now you'll see I have miles on the denominator. So how do I get rid of miles? Well, 600 miles. So if I do 600 miles, 38 miles per gallon at 19.8 pounds per gallon, I will end up producing 312.63 pounds of CO2. Number 3. Now let's go to electricity. How much CO2 is produced by using a laptop for 6 hours? Well, a laptop uses 50 watts. So recall that when we're using electricity, we always start with watts. 50 watts over 1. We need kilowatt hours. So 1 kilowatt is 1,000 watts. That makes my watts disappear and I'm in kilowatts. Well, now, how many hours did I use this item? Well, 6. So now that I have kilowatt hours, I can do the 1.37 pounds of CO2 over 1 kilowatt hour. Because kilowatts go away with kilowatts, hours cancels out with hours, I'm left with pounds. So when I multiply in the top and divide by the denominator, I get 0.411 pounds of CO2. Number 4, suppose your water softener runs for 20 minutes every night. How much CO2 is produced by using the water softener system for a year? Okay, well, let's think about this. I need hours for CO2. So 20 minutes, change that to an hour by divide by 60, right? Because there's 60 minutes in an hour. And we want to do that for 365 days. Okay, let me explain that better because I don't know if that was very good. If we do this for 20 minutes, there are 60 minutes in an hour, which is what we want, right? That makes the minutes go away. And there are 365 days that we're doing this because we're doing it for a year. So that's why we take 20 times 365 divided by 60. We are doing this for a total of 121.67 hours. We need that. We need the hours. The water softener uses 2 watts, which seems really low, but I checked it and it's true. So if we use 2 watts and then 1 kilowatt over 1,000 watts, that makes our watts go away. Then how many hours? Well, we just found 121.67 hours. And once we have kilowatt hours, then we can do the 1.37 pounds over 1 kilowatt hour. Kilowatts cancels out with kilowatts, hours cancels out with hours. Do the math, and that is 0.33 pounds of CO2. Not a whole lot, not a whole lot. Now, part B, it says, what if you are charged 10 cents per kilowatt hour? How much money does this cost over the year? Well, you start the same, 2 watts, 1 kilowatt over 1,000 watts, right? Your watts cancels out. How many hours? 121.67 hours. But now we use the 10 cents over 1 kilowatt hour. So we still have these things canceling out, and we end up with 2 cents. So your water softener is going to cost you 2 cents over the cost of a year for the electricity. Number 5. According to recent data, Americans spend an average of 34 hours per week watching TV. Assume the average American watches an LCD TV, which means 250 watts, estimate the CO2 emission caused each week by the average American. So, 250 watts, we do 1 kilowatt is 1,000 watts. Okay, so that makes my watts go away. How many hours are we doing this? Well, 34 hours a week. And that's what we want. That's each week, but we want to know about each week. So it's just 34 hours. Now that we have kilowatt hours, we do the 1.37 pounds is 1 kilowatt hour. Kilowatts, kilowatts, hours, hours. I do the math, and I get 11.645 pounds of CO2. And the last problem. If we assume Americans watch 34 hours of TV each week, and they do not unplug their television, how much CO2 is caused from the vampire energy used in 1 year? Okay, now think about this. We watch 34 hours a week. That means all the rest of the hours for the week is vampire energy. Well, 24 hours in a day, 7 days in a week, there's 164 hours in a week. So if we watch for 34 hours, that means there's 134 hours we don't watch TV. And really, what else are we doing? Okay, so this is the hour, this is per week. Well, how many weeks are in a year? 52. So 134 hours a week times 52 weeks in a year, there are 6,968 hours we don't use the TV. So this is the hour that we're going to use. So 6968 hours. The watts of a TV on standby is 3.06, and I think that's all we need. So we start with our watts, 3.06 watts times 1 kilowatt is 1,000 watts, right? Cancel out my watts. We found our hours to be 6,968, and you might do that a different way, but I went, by weeks and 52 weeks in a year. And then once I have kilowatt hours, I do 1.37 pounds is 1 kilowatt hour. So kilowatts cancel out with kilowatts, hours cancel out with hours, and I have 29.21 pounds of CO2. And that is your practice with carbon dioxide emissions.